Stoichiometry is the study of quantitative relationship in chemical reaction, allowing chemists to predict how much product forms from given reactants and vice versa. By using balance equation and the mole concept, stoichiometry bridges the gap between the atomic scale particles and measurable quantities like grams, liters. For example, it can determine how much oxygen is needed to burn a fuel completely or how much medication can be synthesized from raw materials. Mastering stoichiometry involves understanding mole ratios, limiting reactants, and percent yield, key tools for both laboratory work and industrial application like drug development, environmental engineering, and energy production.
For the material, we use measuring scale, lighter, candle, and transparent glass jar.
The first step to this experiment is to weigh the candle using the measuring scale and record its initial mass. Then, the candle is lit by the lighter for 10 minutes.
Much later.
Next, a transparent glass jar is carefully placed. After that, observations of the flame is made. The transparent jar is removed once the flame extinguishes as the candle cools down. The candle is weighed again using a measuring scale, and the final mass is recorded. Lastly, any changes are observed, such as spot formation or condensation in the jar is recorded.
In this experiment, we were able to determine the stoichiometry of candle combustion by weighting a paraffin candle before and after it burned. A practical illustration of a hydrocarbon reacting with oxygen to produce carbon dioxide and water vapor is the candle's combustion, which is CxHy, that is wax, plus O2 equals to CO2 plus H2O. Commercially, candle or paraffin wax usually mixtures of alkanes, stearic acid, and other additives that can be expressed as C25H52. The availability of oxygen indicates the burning of candle is complete or partial combustion. Complete combustion means that all wax turns into CO2 and H2O, while incomplete combustion, carbon monoxide or black soot instead of CO. The oxygen in glass jars slowly runs out when it was placed over the flame, showing how important oxygen is to maintain combustion. Mass loss from gases escaping before weighing or form using a balance or negligible. The amount of hydrocarbon used is shown by the mass of wax burned. The wax turns into gaseous products, which is CO2 and H2O, but does not disappear. The chemical change demonstrates an interaction with oxygen, suggesting that fuel, which is wax, and oxygen have a stoichiometric relationship. It is a reactant because the flame extinguishes when oxygen is no longer present. Stoichiometry can be used to calculate the theoretical mass of carbon dioxide produced and the mass of oxygen consumed.
The experiment demonstrates that mass can be conserved in a chemical reaction, even though gaseous products may not be easily be captured or be measured. This supports the law of conservation of mass that said the total mass of the substance involved remain constant before and after the reaction. It's connecting directly with stoichiometry principles such as balance equation and mole relationship.
Thanks for watching.
Yeah.
Please subscribe.